Okay. So this is Unit 3, Lesson 3, Nuclear Equations, Nuclear Energy. I'll try to talk a little bit about fission and nuclear chain reactions. We got a lot to squeeze in today, so some of this might have carried over into Monday. All right. Madeline, can you remind me, what is the purpose of an unstable nuclei to go through decay? That's it. So to cover our bases, guys, we have discussed what Madeline just said. We have discussed how unstable nuclei decay naturally, I want to emphasize the word naturally, to become stable. This results in a new element. So an example that we have done several times here, I'm going to do it again. Can you tell me the name of that isotope? Again, that version of uranium, what is it? This is called uranium-238. I know it is uranium because it has a big old U there. I also know it is uranium because it has the number 92 as an atomic number. And the only element in the universe with 92 as an atomic number is uranium. Uranium is going to undergo alpha decay. And it will become thorium-234. That is the new element. That's what I'm talking about. I'm not talking about something just totally out of nowhere. I'm talking about an element on the periodic table is what uranium changed into. This is called transmutation. Transmutation is the term you got the other day. It basically shows how an element like uranium becomes thorium. Thorium becomes radon, radon becomes polonium, and eventually becomes lead. And then it's stable. But what now I'm going to tell you is we have figured out how to do this synthetically. We know it occurs naturally. Like we know how a human is created. Sperm fertilizes an egg naturally. You have sex, sperm fertilizes the egg, done. But we know how to do that artificially. Some of you might be an IVF baby, in vitro fertilization, where a sperm and an egg were put together within a laboratory, and you had a zygote, then an embryo, and eventually you were placed back in your mother's womb, abracadabra, 9 months later, here you are. So we've learned how to do a lot of naturally occurring processes artificially. And that's what I want to pick up on. There's a guy that we discussed before. He discovered protons. His name is Rutherford, Ernest Rutherford. Ernest Rutherford proved transmutation can be artificially induced. Have you ever gone to the beach before? Have you ever gotten a tan before? That's naturally being on the sun. By the way, tanning is a defense mechanism. It is a known fact that darker skin is harder to burn. Burning is bad. So your skin will release more pigment to try to protect yourself from the sun. Well, we know how to do tanning artificially. A couple ways. You can go to a tanning salon. There's one on Swan and Dale Mabry. You could do the old spray thing. There's artificial ways to manipulate something that is a naturally occurring process. Okay. Transmutation is one of those things. So in 1919, a little more than 100 years ago, Rutherford bombarded nitrogen 14 with high-speed alpha particles. Here are the results. He didn't know what was going to happen, guys. You got to understand the thing about science. Sometimes you just perform an experiment and you record your results, whatever they are. And then you do it again, see if you get the same results. Then you have a buddy do it, see if they get the same results over and over and over. You got to see what the outcome is. Sometimes they don't know what the outcome is. They can try to predict it, but you don't know for sure. Here's what the outcome was. Here's the alpha particles. Here's nitrogen 14. He did it in a controlled environment. He made oxygen 17 and he made hydrogen 1. Now, you might be saying, okay, well, we've been talking about this for the past couple of days. What's the big deal? Here's the big deal. What we've been talking about the past couple of days has been naturally occurring. It happens all on its own. Humans don't need to guide it. This was human-guided transmutation, artificial. This opened the door for a lot of possibilities. The major significance in all of this. What is the big deal? The significance is this proved that scientists can create hundreds of new isotopes and even new elements on the periodic table. So isotopes, if you haven't remembered, they're atoms of the same element. They could be oxygen isotopes. It could be carbon isotopes. They're all the same element, but they have different mass numbers. There's carbon 12, carbon 13, carbon 14. Those are isotopes. There's uranium-235. There's uranium-238. There's uranium-237. Those are isotopes. They're all the same element. They just have different mass numbers. We've been able to make hundreds of new isotopes that can't be found in nature and new elements. That's the big deal. And I really want to try to put myself in your brain so you can try to put yourself into my brain. You all see this giant periodic table that I have behind me. When I was in high school 20 years ago, this row did not exist. I'm serious. It didn't exist. It was a blank. In fact, to prove my point, if you go down about 2 or 3 classrooms down South Hall, there's another chemistry room. I think it's Miss Marr. She's on the other side of Miss Roy. I'm on this side of Miss Roy. She's on the other side of Miss Roy. She has an old periodic table hanging from her ceiling. This row's gone. That periodic table she has is like from the 80s. It's ancient. This one I got like 2015, so it's not that old. All this stuff is brand new, and these are the newest 4. I think these were discovered in 2014. Y'all were alive when those were found. These elements do not occur in nature. These down here, they don't occur in nature. Everything that is written in white letters on this periodic table behind me are made in a lab. Some of them only last for a second, but they existed. Some of them are used all the time. Plutonium. You hear it mentioned in pop culture all the time. If you ever saw Back to the Future, the time machine runs on plutonium. Plutonium and uranium was used when Oppenheimer and his team of scientists created the first atomic bomb ever. It's radioactive. Americium, where are you? Right there. That's used as smoke alarms. You probably had that in your house. And as you can probably tell from the name, if you discover it, you can name it whatever you want. That's named after America. That's named after Niels Bohr. He's a scientist. Guess what city that's named after? Guess what state that's named after? Guess what? Where are you? Look at that. Ernest Rutherford. So you can name it whatever you want. Name it after a person, name it after a place, name it after a thing or a mythological person. These are called trans-uranium elements. And there have been a decent amount of these elements that have been created during your lifetime. New elements. Uranium is the largest naturally occurring element. It is number 92 on the periodic table. But it is not the biggest element on the periodic table. All elements beyond uranium are man-made. We call that synthesized. And they are called the trans-uranium elements. So I want to take a break from your notes. I told you I got some videos to show you today. I'm going to pause the video right now, pause the recording.